In this demonstration, we'll explore the benefits of the new floor wall machining command in NX 8.5. In this setup, I have my blank defined as the rectangular outline that you see. It's an aluminum billet. The part is blue, and my fixture elements are red. Let's get started. First, we're going to machine the top off this part. The floor wall machining command requires a minimum of inputs to get good results. I'm going to use a 3/8 end mill and a mill finish method. On the screen you see the stock as it exists when the operation starts. I'll select a floor. This will automatically set the tool axis, and in the light green color you see the region that's defined by that floor. What it does is extend the face to the extent of the remaining stock, so that when I generate, it automatically takes all the top off of the part. Let's switch that to a zigzag so it's a little more efficient. The floor wall machining command will automatically keep track of this remaining stock, which we call the in-process workpiece, or IPW. For our next operation, we'll machine the front of the part off. Again, I'll select just a single face, and it shows us the region that could be machined by that geometry selection. But I'm really not interested in cutting up into this area right now. So I'll uncheck automatic walls and change that region by selecting two faces, here and here. Even though there's an undercut, the software doesn't get confused, and it correctly identifies the region that I want to machine. We'll switch here to a follow part strategy and generate. Here's all the passes needed to take that material off. Let's continue with this orientation, and I want to cut around the periphery of the part. In this case, I really don't have a floor to select, but that's okay. I'll just select walls. I'll work my way around, and I'm careful to pick up the chamfers as well. But here I'll stop my selections and watch what happens. The software automatically creates a region by extending that chamfer out. Then the tool checks against the wall that's there and continues on until it gets to the extent of the stock again. Since we have no floor, we'll set our ZM axis, or our tool axis. Next, we do want to change to a profile, and I'm going to put in a Z-depth offset, which is saying that I want to cut a little deeper than where that wall ends up. I want to go just below it by 20 thousandths. Next, I'll go to my cutting parameters and set my tool overhang. As you can see here in the image, this is what the tool overhang allows, the amount that can extend over the wall. And there is my result. Next, I'll work on this area here. Here's my floor, and that region looks fine, but if I want to, I can go in and select a wall. And you can see that it's going to cut too far back and get right into my fixture. That's easily resolved. I go to my cutting parameters and just assign some stock to my check boundaries. That's the correct region that's being cut, but my tool can't really go that deep. So let's give it some additional passes in Z as defined by the step down. That looks much better. You can see how the floor wall machining command keeps track of all the parameters in the machining process, though. Here it starts the passes farther to the left because it knows that that stock's already gone. As I get to the bottom, though, the passes have to come further out. It's the same situation with the check stock. As I get closer to my clamp, the passes can't get in as deep. One of the problems that we run into with programming is that as we get to the end of our process, sometimes we get a better idea for how the process could be run more efficiently, but going back and making that change can be difficult because all of the lead-ins and lead-outs have to be manually recalculated. With NX 8.5, those details are taken care of for you automatically. So let's say we want to make a change here where we really want to make this operation occur last. So what's going to happen then? I'll drag and drop this operation in front, and to get it to update, I just regenerate. It now recognizes that that material exists all the way down, so you see a change to the lead-ins here. And this operation that used to go all the way to the wall and come up stops right at the end of the chamfer because there's no more material left to cut. All we did was drag and drop to change the orientation, and then we regenerated. Now let's work on these features here. This time I'll switch to a smaller cutter. And again, I'd like the follow part strategy. Let's change our overhang. And now we've machined that out. However, our 1/4" tool can't fit into these little ears. Well, that's not really a problem. We can just copy and paste that. So I've made a copy of the operation, and now I'll paste it. Instead of just regenerating it, I'll change my tool. We'll select an 1/8" tool and then regenerate. So this operation now does nothing except just clean up those two little areas that were remaining. Finally, we'll focus on this angled pocket on the front of the part. I'm going to start with an operation that uses a straight end mill. We'll rough it out, then we'll come back in later and finish it. Because I'd like the passes to taper in as I come down the wall to remove the most material, I'll want to make sure that my cut region containment is walls rather than floors. Let's just specify the floor. We'll let it find the walls automatically and generate. Let's look at the remaining material, and we can see that in fact our passes are stepping down. One change we might make is to reduce our depth per cut so we get a couple more passes. Okay, let's go on to our finish pass now. Here we'll use an angled cutter. Our floor is specified. Again, we have cut region containment set as our walls. Finally, we'll focus on this angled pocket on the front of the part. I'll begin with a small diameter cutter. We've set the cut region containment to walls because we want the passes to cut as close as possible to the wall as we descend down into the pocket. First, I'll specify the floor. Then we'll go to the cutting parameters, and we do want to leave some material on those walls. So I'll just set 10,000ths here. Our depth per cut is 60. We'll generate, and we'll see that in fact those cuts are tapering as they move down into the pocket. And here's the resulting material. Now let's move on to our finish pass. This is a tapered cutter. Again, we just need to select the floor. Our region containment is set to walls and will generate. To finish up, I'll zoom out and we'll run the whole program in verify mode. And then there's our finish pass. That concludes then our presentation of the 2.5D volume milling in NX 8.5. Let's move on to the next topic in the presentation.